Hello everyone, welcome to my channel CISC Topper Classes. Today we are going to discuss chapter 10 Triangles exercise 10.1 question number 1 to 12 of M.L.aggarwal class 9th mathematics. So let us start solving this exercise here in this video.
Here we are going to do chapter 10 triangles here. So chapter 10 triangles. Firstly, we have to know here some things which is important, which I am going to use frequently in this exercise. First is scale and triangle. As we know, as we have already learned about this triangle also, that if all the sides of a triangle are unequal, all the sides of a triangle are unequal, then it is called a scalene triangle. It is called a scalene triangle. And the second part here is we have the second type of triangle is as isosceles, in which two sides of the triangle are equal. So here this is isosceles triangle. If any two sides of our triangle are equal, it is called isosceles. The third type of triangle here is equilateral triangle, in which all the three sides are equal only. Equilateral triangle. Here we have all the sides, all the it is three sides of a triangle are equal here. Now, the second types of triangle on the basis of angles are also there. This is on the basis of sides we have, and the second type is on the basis of angle. On the basis of angle here, we have the first part as acute angle triangle. So this is acute angle triangle. Second part here is right angle triangle. So this is here right angle triangle. Now we have the third type as obtuse angle triangle. So these are the all types of triangle. Now the main thing which I'm going to use here, that are the theory. So the first theory is SSS rule, means side congruency of triangles. So SSS, and the second rule to prove two angles equal will be SAS, side angle side here. So these two theorems which I am going to use in this exercise to prove the triangles congruent here. So let us start solving this exercise. Now let us solve exercise 10.1, first question. So the first question here says that it is given that triangle ABC is congruent to angle RPQ, and it is true to say that BC is equal to QR. So firstly we will make a triangle here which is something like that. So let it be ABC, and here the second triangle as RPQ. These are equal triangles, mean congruent triangles. So can we say that BC is equal to QR here? No, because the same sides should be congruent in congruency. Means BC is equal to PQ, not QR. And the question says here we have to tell that it is true that BC is equal to QR. So it is not true. So no, the reason here is why. because BC and QR are not corresponding sides. In fact, sorry, it is here BC is equal to PQ. So this is true, but this is not true here, means this is not true. Now here we are going to solve the second part, which says that if two sides and an angle of one triangle are equal to two sides and an angle of another triangle, then the two triangles must be congruent. Is the statement true and why? So firstly, it is not true in SAS rule of congruency, that if two triangles are there, and it doesn't mean that an angle and two sides of a triangle are equal to two sides and an angle of another triangle. This doesn't mean. It should be the angle which is included between two sides. Means, like if this is the triangle here, let it be this is the side and this is the side, and let it be the second triangle. Here this side is equal to this side and this side is equal to this side. So this should be the angle which should be equal, and this should be the angle between those two sides which are equal. Means if AB, let it be ABC, and here PQR. So if AB is equal to PQ here and AC is equal to PR, then simply the angle should also be equal. Means angle BAC means the angle between those two sides which is equal should only be equal here, so that to prove the congruency of triangle. Means here BAC should be equal to QPR. So this is the angle here. From SAS rule of congruency to prove that two triangles are equal. Hence, from here this given information, it should be an included angle here between the two sides. So from here we have the answer as no, this statement is not true, because the angle should be an included angle. Included angle. In the adjoining figure here, in the third question, AB is equal to AC, means this side is equal to this side, and AP is equal to AQ. AP is equal to AQ. We have to prove that triangle ABC are congruent to triangle AQB, means A PC, APC, and here AQB are congruent triangles. So to prove this, firstly we can write here the given information as AB is equal to AC here in this triangle APC, and here AQB. AB and AC are equal. So this is given. Now here AP is equal to AQ. This is also given. And in both these triangles, angle A is common. Hence angle A is equal to angle A. So this is common. We can simply write from here as triangle APC is congruent to triangle AQB by SAS rule of congruency, because this is the angle between included sides, means the included angle. So by SS rule of congruency we have proved here this part. Now the second part here which we have to prove is that CP is equal to BQ, means here CP is equal to BQ. So CP is equal to BQ, hence proved, because it is the part of the triangle which we have proved congruent. Hence CP is equal to BQ by CPCT. Now the third part which we have to prove here is angle APC. APC and AQB are equal. We have to prove that APC and AQB are equal, means these are also equal by the congruency of triangles which we have proved. So this is also by CPCT we can prove. Let us solve the fourth question here, in which in the adjoining figure AB is equal to AC and P and Q are the points on BA and CA respectively, such that AP is equal to AQ. Then we have to prove that angle APC and angle AQB are equal. So firstly, from the given information we have to prove this, as AB is equal to AC, which is the given part, and AP is equal to AQ. This is also given. And P and Q are points on BA and CA. So as the angle A opposite to these angle is vertical opposite angle. So these angle are equal. So we can simply write it as angle QAB is equal to angle PAC from vertical opposite angle. From this information we have find the angle also. From the SAS rule of congruency we can prove that angle triangle APC is congruent to triangle AQB by, because the angle here is included angle, by SAS rule of congruency here. Now let us solve the second part here, which is CP is equal to BQ, means this CP is equal to BQ here. So again this is from this congruency also we can prove that it is CPCT, means CP is equal to BQ. Here this is CPCT. Again the triangle angle ACP and angle ABQ from CPCT they are also equal. Angle ACP is equal to angle ABQ from CPCT also only. Now let us solve the fifth question here, in which in the adjoining figure AD is equal to BC, means AD is equal to BC and BD is equal to AC from here. Then we have to prove that angle ADB and angle BCA are equal and DAB and CBA are equal. So firstly we can prove that this triangles are congruent. ABD and BC, as a hint is given to us, means this triangle we have to prove that they are congruent. So simply here the given information is AD is equal to BC. So this is given only. Now we have this is BAC, means ABD and here BAC we have to prove. So AD is equal to BC. Again the given information is BD is equal to AC. This is also given here, means BD is equal to AC. From here we can say that the line which is common, means here AB is common in both the triangles. This is common, hence we can prove from here that triangle ABD is congruent to triangle BAC. Now again we can write here that angle ADB is equal to angle BCA. So the first part is ADB is is equal to BCA from CPCT by this congruency which we have proved here, SAS congruency. So this is CPCT here. Now the second part is also by CPCT. DAB is equal to CBA, means DAB is equal to CBA. This is again from CPCT we can prove. Now let us solve the sixth question here, in which ABCD is a quadrilateral in which AD is equal to BC. Means the given information to us is AD is equal to BC. This is given. And angle DAB, means DAB is equal to angle CBA. So this is also given DAB is equal to angle CBA, and from here only we have common as AB. So AB is equal to common here. So simply by SAS congruency we can prove that triangle ABD is congruent to triangle BAC. So simply by SAS rule of congruency, SAS rule of congruency, because the angle here is the included angle between the sides AB and BC, and here AB and AD. So this congruency will be used. Now the second part which we have to prove here is BD is equal to AC. Means this BD is equal to AC. So from this triangle congruency we can prove it by CPCT. Again we have to prove the third part here is angle ABD, angle ABD and angle BAC. Angle ABD and BAC are equal from CPCT only. Let us solve the seventh question here. In that joining figure, AB is equal to DC here and AB is parallel to DC. Means this is parallel to this DC. So we have to prove that AD is equal to BC here. Means AD is equal to BC. So simply firstly we will have that AB is parallel to DC. Means the angle from here, alternate angle will follow, means angle ABD and angle CDB are equal. Angle ABD equal to angle CDB from alternate angle. So these are angles which are equal because the two lines are parallel here. And here the given information is AB is equal to DC. So this is given information. And ABD and here CDB has common as DB. So DB is equal to DB, which is common here. So this is the common line. So we can simply use here SAS rule of congruency, uh, because AB and DB are equal and the angle between them means ABD and CDB are equal. So these are the angles which are equal. So we can simply write it as triangle ABD is congruent to triangle CDB, CDB by SAS rule of congruency. So from this congruency we can prove that here this line AD and BC are equal in the triangle. So AD is equal to BC from CPCT. Now let us solve the eighth question here, in which given is that AC is equal to AE and AB is equal to AD here. So we have to the angle also it is given that angle BAD means this angle and angle CAE are equal. Means these angles are equal here. So firstly we will join this to prove two triangles as equal. So joining DA we can simply prove that from the given information only that this BAC and DAE are equal. So firstly we can prove here that given information is AC is equal to AE. This is given, means AC is equal to AE here and AB is equal to AD, means this line is equal to this line. And that from the this also we can write it as angle BAD plus angle DAC. So from here angle BAD plus angle DAC is equal to angle CAE plus angle DAC. So these two angles are equal only. So simply we can write it as angle BAC is equal to angle DAE. So here this is DAE. So this is also given only, and hence we have proved here also. Hence proved that the triangle ABC ABC is congruent to triangle DAE, means this triangle. So from here we have proved that these two triangles are congruent by SAS rule of congruency, because the angle which is included here is the included angle. So now simply we can prove that BC is equal to DE because of CPCT in the two triangles. Now let us solve the ninth question here. In the adjoining figure, AB is equal to CD here and CE is equal to BF. Angle ACE is equal to angle DBF. So we have to prove that triangle ACE is congruent to triangle DBF. Firstly, we can write as, according to the given information, AB is equal to CD, and here uh, we can write it as BC is equal only. So AB plus BC equal to CD plus BC. So we can simply write here as AC and here BD according to the hint also which is given here. So from here we have proved that AC is equal to BD, and both the triangle, the given information here we have proved it, the first part. Now the second part here, the given information only is CE is equal to BF. This is given to us. Third part is also given to us, that angle ACE is equal to angle DBF. This is given to us. And from these three information we can prove that the first part here in the question, that triangle ACE is congruent to triangle DBF by SAS rule of congruency. So here we have proved, because the angle which is used here is the included angle only. So we can use the theorem SAS rule of congruency to prove these two angles equal. Now we have to prove that second part, AE is equal to DF. These are the sides of the triangle which we have proved only, means this AE and FD. So simply we can write that AE is equal to DF by CPCT. It is proved here. Now let us solve the 10th question here. In the adjoining figure, AB is equal to AC and D is midpoint of BC. Use SAS rule of congruency, SSS rule of congruency to show that triangle ABD is equal to triangle ACD. So to prove this first part, we can simply write the given information firstly, that AB is equal to AC. So this is given to us. Now we have D as midpoint. So simply we can write BD is equal to DC from here, by, because D is midpoint. Now the third part which we can write here is AD is common, means AD is equal to AD. So this is common here in both the triangles, hence it is equal. From these three given information, we can simply prove that ABD is congruent to triangle ACD by SSS rule of congruency. And simply the second part also from this only, because AD is bisector of angle A from here. So this we can prove by CPCT, that angle BAD is equal to angle DAC by CPCT only. And from this given information we can write that AD is bisector of angle A. Now the third part, which is we have to prove that AD is perpendicular to BC. Because it is a straight line, we can simply write that ADB plus angle ADC is equal to 180 degree. From here we can simply write that it is because ADB and ADC are equal. From CPCT we can write it as 2 ADB only, which is equal to 180 degree, and from here 1 ADB, because ADB is equal to ADC by CPCT here. Hence we have that ADB is equal to 90 degree, which is equal to ADC also. So here we can simply write this, and hence proved that AD is perpendicular to BC from here only. Now let us solve the 11th part here, which is two line segment AB and CD bisect each other at O. Then we have to prove that AC is equal to BD, means AC is equal to BD here. So simply we can write as first part AC is equal to BD. So AC is equal to BD here. Simply it is because in triangle we have to prove in triangle COA and triangle BOD we have as CO is equal to OD. CO is equal to OD because they bisect each other at O, and AO is equal to OB because they bisect each other at O. So now we have because of vertical opposite angle as COA. Angle COA is equal to angle BOD because they are vertically opposite angle. From this only COA is equal to BOD. We have vertical opposite angle, and we can prove that triangle COA is congruent to triangle BOD. And by proving this only, we can write as AC is equal to BD. So hence this is proved from this congruency, which is because of SAS rule of congruency. So by CPCT, we can simply prove that AC is equal to BD. Now, the second part which is here is CAB is equal to ABD. So because these are two adjacent sides, so we can prove that angle CAB is equal to angle ABD because of alternate angle here. Here we have this as alternate angle also, but from this congruency we can prove them also equal by CPCT. And this alternate angle we will use in the third part to prove that AD is parallel to CB. If these two angles are equal by CPCT and they are alternate angles also, so we can simply prove that AD is parallel to CB. Hence the third part is proved here. Now the fourth part is AD is equal to CB. AD is equal to the fourth part we have to prove that AD is equal to CB only. So in triangle here, in triangle AOD and triangle COB, we have as CO is equal to OD and AO is equal to OB. So simply we can write here angle AOD is equal to angle COB because of vertical opposite angle, and from these three things we can prove that triangle AOD is congruent to triangle COB, and from here simply by CPCT we can prove that AD is equal to CB from CPCT. Now let us solve here. In the adjoining figure, find the values of x and y, the 12th question. So simply firstly we will prove that let it be A, B, C and here this be P. So here given information to us is from this diagram AB is equal to BP and AC is equal to PC. From here only we have these because the two sides are equal, so simply we can write that BAC is equal to BPC as equal. So here we have BC as common in this. So BC is equal to BC. This part is given to us. This is also given to us. And here this is common in both the triangles. So hence proved that triangle ABC is congruent to triangle TBC from here given information by SSS rule of congruency. Now simply we can find the value of x and y by putting that ABC by CPCT. We have got it as ABC is equal to angle CBP, and here the angle is y plus 5 degree equal to 46 degree. So y is equal to 41 degree, and here again ACB, this is the first part which we have to find, means the value of y, and the second is ACB is equal to angle ACP, and here this is 35 degree is equal to 2x plus 5 degree, means 30 degree is equal to 2x. So this will be cancelled out, and here we will get 15 degree as the value of x, and this as 41 degree. So this is the answer of the 12th part here. So x is equal to 15 and y is equal to 41.
Thank you for watching my video. If you like this video, please like, share and subscribe my channel.